All right, folks, thanks for coming to our first of another round of OMFIT tutorials. As Will put together the slide here on the left, he shows the very first OMFIT workshop happened 10 years ago. It was actually 11 years ago. I looked at the Monday, February 11th to correlate it. And, you know, OMFIT started as a postdoc project for Orso Meneghini. And then I quickly joined on, recognizing the power of what he was trying to do. And so, you know, it's been around for a while. I think there's some definite strengths to it. And it's good to have Will as a new person. You know, he came from the aerospace industry. He has a different background than Fusion, but he has coming into OMFIT, he recognizes what its strengths are and comes as a new user. So whereas some of the maybe previous OMFIT tutorials, especially the intro tutorial, was kind of developer focused, you know, Will really brings a user perspective. So happy to have him come up and go through the intro, the OMFIT overview of this OMFIT tutorial series of 2024.
Thank you, Sterling. Okay, so thank you everybody for coming and joining us. This tutorial, first of all, my name is Will DeShazer. I've been with the CSS group for 2 years now. I started back in January of 2022. And when I was hired on, one of the things I did was take over the maintenance or the ownership of OMFIT. So that's why I'm here to talk to you today. Basically, the content that we're going to talk about today is really an overview. And since I've been here, in the 2 years that I've been here, I've had to support field many different questions. And so, you know, there's still things that people don't understand about the core concepts of OMFIT. So hopefully when we get done with this tutorial, you will have an appreciation for some of those things. Also, if you have experience with OMFIT, this may be a little bit below you. So enjoy, and I hope the pizza satisfies you. All right, so as far as the overview, these are the things that I'm hoping that you walk away with some sense of when we're done. First, what is OMFIT and what problems does it solve? You know, the structure of OMFIT is also very important, and having an understanding of the structure can help you with troubleshooting. Getting started with OMFIT, you know, there's a question about how do you actually do that? You know, what is a workflow and what is a regression test? My hope is that you'll have a good sense of what that is when you leave this meeting. And then the structure of a project, which is different than the structure of OMFIT. And again, hopefully by the end of this, you'll have an appreciation. And then finally, when do you need the developer workflow? Because we'll go through that. Anyway, so what I'm going to start with, what is OMFIT and why OMFIT? So what is OMFIT? OMFIT is really about trying to enhance and extend present modeling capabilities by supporting and leveraging, integrating existing research. So, you know, oftentimes when you're doing studies, you're pulling together various tools to try and come up with an integrated design or integrated research. And so OMFIT is really about trying to make that process easier and more seamless so that you can focus on the physics and less about how you tie programs together. So how does it do that? Well, OMFIT is really a hybrid between a workflow manager and an integrated development environment. And this statement is a really big statement. And I believe really when I think of OMFIT personally, I think of OMFIT as being a tool that is not really just specific to fusion research. It's been very geared towards fusion research because, you know, Orso and Sterling, this is their baby, but it really is something that is applicable across industries. So first we'll start with the heart of OMFIT, which is the tree. So one of the things about the OMFIT tree is that the paradigm really treats files, data, and scripts as a uniform collection of heterogeneous objects. And that's the important part. Because of the way the paradigm that OMFIT incorporates, these objects can be treated fundamentally to a large extent as the same thing, which means that you get predictable behaviors from these things when you're trying to integrate them. It kind of abstracts and separates that. And that's very useful for getting the job done. It provides a consistent way to access and manipulate. So one of the cool things is objects can move within the tree, and they can be nested. So you could take a module and put it as a submodule of another module. And we'll talk about why you would want to do that and what the benefit is. But in general, just having that capability enables you to do complex compound tasks. Over here, just for the illustration, this is what the tree looks like. This is the tree view right here. And you can see nested modules and objects within it. So OMFIT features. Let me move this out of the way. Yeah, OMFIT features main GUI, data formats, and actions. So the top level GUI is tightly integrated with the OMFIT tree. The whole intent of that top level GUI is to really give you a sense of what your data is and relationships between that data. So that the top level GUI gives you the ability to manage those objects. It gives you the ability to carry out simulations. Sometimes you can just literally just double click and you'll get behaviors because it knows what to do with certain types of objects. And then it allows you to analyze data interactively. So we'll illustrate some of that, but you can see on the right, just the kinetic EFIT time and equilibrium right there. So one of the other features and advantages of OMFIT is that it has built-in compatibility with a lot of scientific data formats. So, NetCDF, Nameless, MDS+, SQL, these are all built in and integrated within the framework. So when you're trying to intertwine modules, you can do it fairly easily, even though they might not necessarily naturally speak the same language. So, and then finally, I said this earlier, but known formats have built-in actions such as plotting. So I want to do a quick aside about integrated modeling and data formats. So when we talk about connecting two codes, there's really two ways. There's probably more ways, but this is the thing that I think is important. There's two ways to think about connecting codes. One is what you call a tight integration. Tight integration typically, I would say, is when you compile the code together, where you share the same memory space, and you usually do these exercises for speed because you want the communication of data to be as quick as possible. One of the challenges with tight integration, though, is that you have to really have an understanding of the infrastructure to make sure that you're making the connections correctly. And so oftentimes these exercises are labor intensive. It takes you a while to be able to get at the data that you want. But the benefit is you get the speed. There's another concept which is called loose integration. And loose integration is really what OMFIT is targeting. OMFIT, a loose integration is basically taking the output of codes that are pre-existing and allowing them to drive and communicate with other codes. And so, really that is one of the pinnacle capabilities of OMFIT is this ability to link through basically a file-based communication. Oh, the nice thing about this is it allows for rapid prototyping. The idea that you don't have to go in there and understand how the code produces what it is. You just say, it does what it does. I just need the output, means that you can then go in and focus on how do I get that output into the input of the other one. And again, this is an exercise that everybody's done. But when you have something that knows how to do formats automatically, so you don't have to do that yourself, you get benefits. Another feature, and I'm trying to take these in steps. so that when we get, so we're building a little picture here. OMFIT Python task is one of the key framework tools that you have. And what it is OMFIT Python task is basically a meta script, which I have it trademarked. Everybody knows that that's my word. Yeah, so it's a meta script, and the meta script is basically Python Python-like. So basically, if you know Python, you'll feel very familiar when you go in there and start coding. It turns out that it will get translated into Python. So ultimately, what is being driven is Python, but it is the mechanism by which we are able to tightly integrate the framework with the tree. So there is a level of infrastructure that you need in place to be able to access the tree as if it's part of your data set. And so that's what the OMFIT Python task does. So for instance, you can specify a location within the tree by basically saying, we'll talk about root later, but you can say where in the tree you want the data to be sourced from, and then you can pass that into another code or wherever you want to do something with it. So that's really what OMFIT Python task does. Also, the OMFIT Python task, it will allow you to be able to call executables at the system level. So that's one of the benefits, is that on the interface level, you're using Python. On the backend side, you can drive system level calls, which means that you can basically use compiled codes to run them and then bring that data back into OMFIT. So it also has it makes it possible to do specialized plotting. So basically you can go in and build plotting scripts, and it also is the workhorse for doing post-processing and passing it into modules. I didn't mention the default vars, but this is the default. The reason why I highlight this is because this is one way where it is not Python. It is this meta script, and when you use in Python, you would say def function name and give it its arguments. In OMFIT Python tasks, you pass data between modules through default vars. So default vars is very much like def, the def command in Python. It has some subtleties there, and I don't want to go into the subtleties for an intro class, but I just want you to be able to understand what's going on there. That this is really the mechanism by which we have interaction with the tree. Finally, OMFIT has a lot of built-in framework stuff for building customized GUIs. So OMFIT uses Python TK as the backend, but the way that it's structured, it simplifies the layout. So you can focus in on flow, not necessarily have to deal with, how do you build a GUI? And trust me, that gets really complicated really fast. The OMFIT GUI, as with the other framework aspects, is really tightly integrated into this paradigm. And so when you're using OMFIT GUIs, it will make it easy to speak to the tree. It'll make it easy to speak to OMFIT Python tasks. The linking of all these elements is tightly integrated within the OMFIT framework. So it gives you, this is the building the structure here. And what it does is it leads to OMFIT's killer features. So you start with the OMFIT tree, which is your data model. You have your Python tasks, which give you a lot of powerful interactions with a minimal amount of thought, because if you know Python, you're going to be very familiar with Python tasks, OMFIT Python tasks, and you have this OMFIT GUI. So then what you can do is take these elements, bring them together, and that gives you this new thing here, which is the workflow and the project. And really, this is what I consider to be the killer feature of OMFIT. And this is the part that would be accessible beyond just Fusion, really, because now you can focus on workflow in the project. And I'm going to talk a little bit why is the workflow and why is the project really a killer feature? And we're going to start with the workflow. So, by itself, an OMFIT GUI shows the state of the OMFIT tree or at that time. So it by itself is static. The OMFIT tree retains the state of the data, but it's the OMFIT Python tasks that populate the OMFIT tree. So the question is, what's missing when you have that? Well, what's missing is the proper sequence of how to do things. And I know that anybody who's ever done a physics analysis will know that, you get a nameless file and you have to go in there and figure out which part of the nameless you need to change. There's a series of analytical steps that you have to take before you get to have confidence that your result is a meaningful result that's been done correctly. But when you have this concept of a workflow, you've distilled that information into an interface. So what that does is a workflow reduces the barrier of entry for new physicists. You can basically say, here's the workflow. If you look at this, you can visualize what the steps are instead of having to go in and read code to understand what the next step, or read a README or read a text file. It's very helpful. It also increases the chances for a valid study. It doesn't make it impossible for somebody to do something wrong. There's plenty of ways you can blow it. But if you know what the recommended steps are by subject matter experts, then you have a better chance of producing good results. And so, in that way, it encapsulates knowledge and best practices from people who know or have history with the tools. And so the next part is the project. And the great thing about the project, I'll illustrate this a little bit more, but the project really takes the entire tree and some of the other elements like the console, history, and the Python environment version information, all the command box contents, and it packages it as a unit and saves it to disk when you want to save it, and brings it back together when you want to revive it. And having this concept of a project is really great, because I'm going to hopefully try to illustrate how bad it can get. So have you ever been into a directory that looks kind of like this, where it's study draft, study V1? These are all basically folders within that folder that contain both your source code. Maybe you inherited something like this. And so it's like you did the study, you made some variations. You made the variations. Some of the variations you made were to the source. Some of the variations you made were to inputs. Basically, you were trying to communicate first to yourself what you were doing, and then maybe to somebody else later. And I was talking with Jeff about this. He used to, in his presentations, he'd put some name like this, study version final in his presentation, so he could correlate the presentation with the data set that was used for that data set. But I can tell you, when you inherit something like this, it is a nightmare. You're trying to figure out, how do they correlate? What's going on? What about 6 or 5 months later? It's an overwhelming effort to find causes of errors, because, and this is an important point, when you have some of the ways that we've all done it, when you put the source in there and you don't have real clear differentiation of function and responsibilities, when you're trying to troubleshoot, you don't know what's happening. And nowadays we have version control. Back in the day, we didn't really even have version control, so you didn't even have history of what the changes were. So trying to troubleshoot can be very, very labor intensive and tedious. And it would often be the way you'd have to start the project before you could even begin doing your research. And so, so hopefully somebody kept some good READMEs. You have to think, was it a source change with experimental data? Was it change like windowing, something that you were doing for the analysis? You'd use a diff to try and figure out the differences between files or whatever. And then finally, maybe there's a better way. So this is the OMFIT paradigm. This is what really begins to hopefully make your jobs easier, is separating function so that, so in this way, Python environment is a whole separate function pillar, and it's maintained in one workflow. OMFIT framework is another pillar. Then you have your physics modules, which is probably what you're more concerned about. And we, in the series, we're going to talk more about the physics modules and less about, core concepts. But, by separating these, it's going to make things easier. And then finally, the project. The project is really where you interact with the analyses that you want to do. And by separating them, you're going to get some benefits. So first, talking about the Python environment. We manage the Python environment through Conda. Conda basically takes a list of libraries and basically will rebuild the libraries wherever you tell it to build the packages. So if you want to install OMFIT locally, you would use Conda to install the OMFIT Python environment. If you want, we maintain an institutional installation through this Conda using what we call the global deployment tool. And when we do that, we version control the environment. And the nice thing about this is that part of the projects don't change rapidly. The environment is actually a slow moving thing. It's not a rapid moving thing. So separating it and getting it out of your face and putting it somewhere and having that be this back-end infrastructure that you don't have to worry about means that most times the issues that you're dealing with when you're not seeing the behavior you want, you can most of the time neglect that part of the infrastructure and focus on the stuff that you were working on and changing actively. The composition of the package, we actually have it separated into two because OMFIT will function with a certain subset of packages. And but some of our modules that we support require optional packages that you might want, that you would have to install if you want the full suite of physics modules locally. But when you're on an institutional installation, like here on Iris or Omega or Portal or any of the other platforms that we support, then you just go in, you do the module load, and all of this stuff comes preloaded for you. So tried to make it fairly easy. This is an illustration of some of the modules that are in the core package. So you have like matplotlib, you have xarray, you have stropy, you have git, h5py, just things like that. So those are all stored somewhere and contained on the back end. All right, the OMFIT framework. The OMFIT framework, I would consider the most important part of the OMFIT framework is the folder. Well, actually, that's not totally true. I gotta be careful. OMFIT has a lot. This OMFIT folder has a lot of the infrastructure that makes the GUIs, that makes the Python tasks, that makes the part that I said was really the killer features of OMFIT. They reside predominantly in this OMFIT folder. And that OMFIT folder has these really very, very fundamental resources. And it has OMFIT classes, which really are some infrastructure stuff that's supporting the physics modules. So some very fundamental ones, which I'm not going to go into detail here, but over time we will cover that in these lecture series. The OMFIT framework, when we say that, this is the reason I'm bringing this up is because this is where I often get confusion. When somebody comes in and tries to install a local installation on their own platform, they don't understand what part is controlled by Git and what part is controlled by Conda. And so you go in and the OMFIT framework part, the stuff that makes the GUI and makes the interaction for the workflows, that's all the Git part. And within the Git, this Git is version control for people who may not be familiar with Git. What that does is it takes the content of files and folders and tracks changes as they evolve through your project. And it does that when you periodically tell it that you've made changes. So you have to push those changes back to a repo. So that's what Git is. And we version control the OMFIT framework through Git. Our version is hosted on GitHub. So basically we have a a version in the cloud that everybody can go to and then pull down their own copy of this version in the cloud. This set of tools is more dynamic than the backend stuff because we're periodically changing it to enhance features, to fix problems that, historically, the backend does change periodically. One of the big things we had to do was make an update to accommodate matplotlib. And so this stuff is more volatile than the previous stuff by design, but it's less volatile than a project. So the project really is the one where you're doing your studies, and that's the stuff that should be changing frequently. But for most users and and even developers, I want to communicate this. This is one of my core points. You don't need to download this to get the most use out of OMFIT. I can't tell you the number of people that go into our OMFIT IO, and one of the first things they do is they go and clone our repository because they want the repo locally. Because in their minds, they have to get the function out of OMFIT, they're going to need the source local on their machine. That's not the case. As a matter of fact, there's a whole class of users who never keep the source on their machine, and they're getting a ton of use out of it. That's because most of the changes they want to make are in the project, not in this part of the infrastructure. So that's the reason I put this up here, is because I had one situation, little anecdote. I had one situation where somebody came to me with a question, and for those of you who are familiar with OMFIT, they launched OMFIT using OMFIT-CWD. So in my mind, that immediately told me they're a developer. They want to quickly go in and start working with the code. I went ahead and tried to help them, take all their changes, bring it back. They weren't doing good maintenance. We ended up spending 10, 15 hours trying to recover. And I found out that -CWD, they didn't even need it. If I could have solved their problem in 5 minutes by recognizing that they didn't really want to touch this stuff and saying, no, just go launch the institutional installation. That's all you want to do your job, and you'll be back in shape. You'll be working. So I could have saved myself several hours, and because people didn't understand that. All right, finally, the physics modules. This is the one that I think people really care about here, because you want to do science. You don't really want to do coding. Maybe you do. I'm a geek. I love coding. But if you want to do science, this is what you care about. But it's important to know that how this is brought together, because when you have problems, you want to be able to troubleshoot it and get back to the science as quickly as possible. And I really do believe that this content, while it may be boring, will help you do that much quicker if you understand the concepts. We have 127 physics modules right now. I did that just by going in and looking at doing a count in the directory. Many of those codes do drive external executables. So like GA code is an external executable maintained. You can build your own executables locally and then tell OMFIT to point to your local version, not necessarily. And again, you don't have to do that exercise by cloning OMFIT. You can actually do that with an institutional installation, and you can redirect it to your local version of whatever it is that you're developing. Again, I'm just trying to save myself headache later. So OMFIT provisions for running local versions and compiled code. Most will drive institutionally. Yeah, I just said that. Many codes utilize, okay. You might be afraid, well, what about parallel processing? Well, OMFIT really is built around accommodating parallel processing. It's got really nice infrastructure for driving parallel processing, and it's got the ability, it recognizes, you can use it if the code itself is using MPI or something else on their side to drive it. OMFIT will work with that. So you really have a lot of power in OMFIT built in. But the nice thing is there's most reasonable defaults and best practice based on workflows. Some of the modules, everybody's familiar. I shouldn't say everybody, because part of this lecture is really geared towards people who are not familiar with this content. But you have EFIT and kinetic EFIT, Variped, gyro, TGLF. The gyrokinetic modules, the transport modules, 1, 2, GCMP, T-gyro. You have GenRay, ray tracing, TorBeam, NewBeam for beam prediction stuff. So you have, these all are already existing within there. So, it's possible to just go in, know what shot number and time slice you want, push a button and actually start immediately producing some results that you can put in a paper. So, that part is nice. Of course, it has to have, you have to know what you're doing because you want to produce something new, but either way. It's continuing to increase. We want it to increase. We want people to understand what OMFIT is good for. And then we want you to go ahead and build out, to take your own modules or your own programs and use OMFIT to do your work faster. Hopefully you'll get some sense that it can be useful for that. Okay, so finally the project side. This is the one that really everybody interacts with. I see 5 things here. Sterling, are you looking at the question, the chat?
Yes.
Okay, thank you. Let me know if I need to stop or something. Okay, with the projects, the nice thing about the project, I already told you about it. It basically saves the state of your analysis at the time that you save it. One of the nice things about OMFIT is it's also auto saving. So say something crashes or something goes wrong, well, there will be there's many times where we can recover the state of your analysis at some period in time. It's the word I'm looking for. It's not coming to me, but that's the nice thing. It's basically got built-in features to save your project. So I said this earlier, that what it preserves the tree, the environment version information, your console history, and also the command boxes. I've seen some people who use the command boxes extensively. Yeah, and I was going to talk about the temporary version and where it's stored, but I think I'm going to move on. This is kind of what a project looks like. So you might have several modules in there, like a 1, 2, and an EFIT, and then maybe your own custom module that you put in. Within EFIT, it'll have a files directory with the files that you maybe G file, K file, and then run scripts will be, that's under the scripts thing. This is an illustration of a typical organization within a tree. Just to give you a visual on how things are organized. The goal of OMFIT is to communicate across the tree, so that content that may be over here in the files G file would drive one of the scripts, like the run EFIT that's illustrated here. But you can have many different, many other types of scripts, and you drive it from the same source data. All right. So this is part where I am intending to go back and just show you how it works. Actually, let me do this. I'm calling an audible here on my presentation. So the first thing I want to just, before I do an illustration, let me show you the top level GUI so you know what I'm talking about. First, we have the tree browser. That's one major component of the GUI. And the tree browser, when I refer to the tree browser, I'm referring to this content section right here. The main thing that the tree browser is for illustrating, is for visualizing the structure of the OMFIT tree. Over here, you have the console. The console is for things that you would normally get in a terminal window that would tell you what's happening with your analysis, like anything that you did with display. That is actually being captured and redirected into your OMFIT session. So that's a running display of what you would normally see in a, well, not just what you would see in a terminal. There's also some OMFIT specific stuff that comes into that terminal, but it will also display what would be normally displayed in the terminal. Down here on the lower right, this is your command box. The command box is great for rapid prototyping. You may not be ready yet to go and save a file, but you do want to go ahead and start manipulating your data. So long as you understand what a tree looks like and how to access a tree programmatically, you can just jump into the command box and start interacting with your tree and doing some pretty powerful and sophisticated stuff pretty quickly. And seeing it real time as you're trying to iterate and figure out, is that the way you want to reduce your data? Yeah, and then down here we have the status bar. And the status bar, you can see down here that you probably can't see it, but like whether your project has been saved, where it's been saved. Up here at the top, you can also see, what build you're at, what date the project had. There's a lot of hidden data that can be important from time to time all around OMFIT, but these are the major components, and you get 90% of it. There's also the menu, which is not highlighted here, but the menu also is very important. Okay, with that said, let's just launch OMFIT. So honestly, when I first started, I was the type of person that wanted to drive everything from my personal computer. I like managing my own resources. I'm that type of person. It took me a while to recognize that, no, this is a situation where it's better to go, especially if you're getting started, go back to the institutional installation and start there. Cut your teeth, get yourself really experienced with OMFIT. And then if you find that it would be beneficial for you later, go back and start actually working with, cloning and modifying and stuff like that. When you're in an institutional installation, first thing you do is just module load OMFIT or OMFIT unstable. Unstable is the volatile branch. It's the branch that's getting the updates as quickly as possible. We have other branches that are being developed and prototyped that are not ready for consumption. Unstable is pretty much ready for consumption. I want to say that. If you need to, I would guess that most people would benefit from just using unstable. If you feel more secure about using OMFIT main, then by all means, stick with that. That is the most stable. That has gone through the most regression tests and has the largest confidence that it is stable. Once you load it, that module statement puts the resources of OMFIT into your path, so that when you want to launch OMFIT, you just type OMFIT. This information, maybe it's intimidating because you see a lot of things running, but what it's telling you is it's looking for all the resources and making sure that the resources correspond to each other. This is, again, another reason why I don't recommend newbies come in and start using their own version of OMFIT, because there is that whole thing that I did before that might have bored you or may have seemed simplistic. That whole thing needs to be somewhat in your wheelhouse and in your understanding internally before I'd recommend, messing around. You'll spend more time messing around with the infrastructure of OMFIT than doing your physics. All right. When OMFIT launches, it starts with this splash window here. This splash is immediately giving you some information. It's telling you the state of the source, what's been changing. So you get the message right here. It's a new release, released December. Is that right? I'm not sure why that is. I knew it was going to happen in a demo. Anyway, that's dated. I just opened it earlier and it opened to. You're on main, are you? Yeah, let's get out of main. I say just press forward. Press forward. All right. I'm going to trust your advice. We're 12:43 now. We have somebody coming in afterwards, so I will probably start winding down here relatively soon. I got through the main content that I wanted to share with you guys. Now I'm trying to illustrate what's happening. So anyway, this tells you what the state of the backend framework is and what's been updated. The three buttons, I used to just immediately go down here to continue OMFIT, not recognizing that Sterling and Orso had put in some thought, and actually these other three buttons are pretty powerful. If you've been working on a project, you might just want to go into the previous project that you were working on. Well, just click that button and it immediately goes through that. You don't have to go in and go to the menu and do file save. You just click that button and boom, you're getting back to where you were at yesterday or at 3:30 in the morning. Next thing is you can open a project. Say you have a project that you've been working on. It's not the one that is the last one, but you want to go to a previous project. Well, then you immediately go in and start opening a project. Finally, importing a module. 9 times out of 10, what you're going to do is go in and import a module. So why not just click this button and save you the steps, because this button will take you to where I'm going to take you right now. If you continue to OMFIT, first thing you would do is come up here to the file, and you would import a module. I am skipping all the issues with setup, just so you know. The setup is, there's some content on OMFIT OI that will show you how to set up. Feel free to look through that. Maybe if we get enough feedback, we'll go back and talk about setup. But when you go to the import module, this is where all of your physics modules are. And the one that I wanted to highlight, if I left you with nothing else, one of the ones I wanted to highlight is this module called tutorial. The tutorial module, I didn't know about for several months I was working here, and I would have benefited greatly from having looked through the tutorial module. So I'm hoping I'm saving you some time by alerting you to this module. This module contains very small examples of different features that you might want to learn from. So it's broken down into scripts here. So just to make sure that you understand what I'm doing, I went and clicked the disclosure button to the left of the left of the tree entry, and that basically said, because one of the things about OMFIT is it's nested. So module within a module or script within a script. These are not the same things as folders, but you might be inclined to think of them as a folder. All right, so the one that I did for illustrating I think I went to, I'm trying to recall what I did for a, so let's just do a basic function. So to open up a file, you hit the space bar. You highlight it and then hit the space bar. And when you highlight it and hit the space bar, that'll bring up an editor. The default editor can be changed. That's actually a user customizable thing. So if you have a preferred editor, you can use that. By default, we use idle or idle 3. And so there was a period where Python 3 was converting from Python to Python 3, and Python 2 was separate, and idle wasn't updated. But I think everything's working now. So you just go in there, hit the space bar, and you can see. Now this one is really very Python-like. So we have the def function, returns x squared. So this was just a very simple illustration. Maybe it was under the GUIs or plots. Okay, let's look at Shot Designer. The nice thing about Shot Designer is it will illustrate the GUIs for you. How to use the GUI elements rather. So in here, OMFIT X.title GUI, kind of obvious name for it. And guess what? It puts a title at the top of your GUI. OMFIT X.entry, that's basically where you create a text box element that you can then pass data into your code. You have to tell it where to go put that data. So it usually goes, many times it'll go and put it in the tree. You can give it a default. You can, on any of these, this is another good thing to illustrate. I also did not recognize the power of this early on. So this is another lesson learned, the help window. So if you come up here to help and you go to the help window, this comes up. And say I want to learn about, say I want to look at OMFIT X.entry. Over here. Oh, well, say I don't know what elements are available to me. That's a good one. This is a quick one. You can just click on the GUIs and look, there's all the list of GUI elements that are available for you to build. Oops. Say you want to use some plots like view 1D or view 2D. you can use the help menu to help you look at what the function is, and then it'll have the help information that'll hopefully allow you to be able to utilize it. Utils. Yeah, here, this one, the math, Butterworth smoothing. You have a lot of built-in algorithms because that's generally useful to the community. So you can access those. You can learn about how to access those going through the help and going through the tutorial to see what they've done. But if this works right, you go to Shot Designer, double click. Generally, if you don't know what it does, try double clicking it. You might see something happen. Could be bad. Most of the time, it's just going to launch a GUI or a plot. So this one, it fetches an equilibrium. So if you look over here, when we fetch the equilibrium, what it's actually doing, that function should be fetch equilibrium. Yeah. Yeah, it's Shot Designer. Sterling? Yeah. Where is it sending it to the OMFIT Python task? I don't see a .run or anything here.
Yeah.
It doesn't do it. It doesn't connect
So
actually.
Line 37 just references the function defined above it.
So, okay, there was some other illustrations that I was playing with last night that actually did things like MDS Plus. That's a useful one. If you learned how to, if you wanted to figure out how to interact with MDS Plus through OMFIT, go in there and look around and you'll find it. It's 12:51 now. I'm close to stopping. The other thing I wanted to show you were regressions. And I want to just go to my slide on that one. I knew I was going to be able to get through all this content. Okay. So another way to learn really quickly is to go to the regression tests. We built the regression tests to make sure that to preserve the integrity of the existing source code so that when people make changes, it'll go in, run the regression test and confirm that existing behavior that we want and we've identified as important is preserved even through changes that people might introduce. So that's great. It functions like that. But it turns out that utilizing regression tests can get you insight in how, it can build existing data resources. So to load a regression test, we have load regression test script over here. When you load, you'll see all these tests, like test EFIT++, test EFIT, test kinetic EFIT time. I've worked with that one a lot. The test Nimrod. So say there's a particular module or tool that you want to learn about, and you don't necessarily have time or have somebody you can ask, you can go in there and look at how the regression test was set up, because let's see if I want MDS Plus, that might be a good one. So there's M's. I know my alphabet. Okay, so when you import it, it'll import like that. Hit the space bar, just like I did before, and it'll open it to the editor. And in here, you'll see how, let's see if I can get to cache cleanup. All right, this would be where the core is. So this particular test is Iris PT data test. Set up environmental variables for local PT data fetching. So basically, it's telling you what it's trying to do. And so when you're trying to figure out how do you do that yourself, so you can replicate it, you can follow the process here and then quickly get up to speed on how to actually do the stuff that you want to do. So basically the two things, tutorial and regression test, those are things that you can take from this and go and learn yourself. Is very powerful. It can do a lot of things and it can get you up to speed quickly. I'll send out an example and explain how to launch your own, but just import it and double click and then look at it for yourself. Oftentimes, double clicking will give you a lot of information. I love the fact that I can just plot equilibria really quickly. Just go in, open it, double click on the tree entry, and it'll plot an equilibria for you immediately. So a lot of fast behavior immediately. So with that, we got 3 minutes, and I imagine Richard Buttery is probably going to want me to be done. So thank you, everybody. I appreciate your attendance.
I just want to say briefly before people in Zoom take off, there will be more of these and they will focus on particular physics modules. So tune back in every 2 weeks and we'll learn about particular GUIs, how to use them, and then more workflow development type things. So stay tuned. And thanks, Will. Great start.
Thank you.